Everyone, in this video I'll be teaching you first come first serve scheduling algorithm. So without further ado, let's get started. Here's a team of friends who planned for a vacation trip, but unfortunately, all of them have forgotten their mobile phone. All they have is just one mobile phone which they have got from one of the passengers. But everyone wanted to talk with her Durania once. So what did they do? Well, Emma was the first person who wanted to talk with her dear Anya one. So she got the phone first and she called her dear Anya one and talked for 10 minutes. Meanwhile, Cheryl also wanted to talk to her dear Anya one, but she had to wait for Emma to complete. So once Emma has finished, she got her chance and she talked for 7 minutes. Then Fina wanted to talk. So once Rita and Emma, both of them has completed their chance, she got a chance and she called it then. Likewise, all the friends got their own chance to speak with the Jorania one by one. So the same strategy is used in computer science to allocate CPU's time to the processes. Well, when there are lots of algorithms, the best, easy and simple one is the first come first serve algorithm which was used long back. Even though now we are having lots of algorithm which is more efficient and better for usage, when you want to learn something which is very easy and simple, the best one is the first come and first serve scheduling algorithm. So without wasting our time, let's learn it. Okay, so now we will be checking out what's happening here. Okay, so here is the example which is given here. So here are the processes P1, P2, P3 and P4. Here is the arrival time. Arrival time is the time in which the process gets into the queue. Okay, burst time is the time which is required to complete executing a process. So when CPU is utilized by a process, say for example process 1, then what is the time which is taken by the CPU to complete executing the process? That is the burst time. Completion time is in real time, at which millisecond was the process actually completed. That is shown in the completion time, and the turnaround time is the total time in which the process was a part of the queue and also was executed by CPU. So all those time bunched into together gives us the turnaround time. To put it in simpler words, it's nothing but the difference between the completion time and the arrival time. Next is the waiting time. Waiting time is the time in which the process was actually waiting to get its time to get executed. It was in the queue, but not still executed. Now here in this example, you can see that here are process 1, process 2 and process 3 with process 4. In examination, you'll be getting just the burst time and the arrival time. You need to compute completion time, turnaround time and the waiting time in most of the cases. Okay, so let's just get started how to calculate these. First, let's start with completion time. For P1 at that time, we can note that no other process is in the queue at 0th millisecond. So P1 is the only process. So CPU gives its time to P1. So P1 gets started to execute itself. So it takes 5 milliseconds. So after 5 milliseconds, P1 is completed. So the completion time is P1. Meanwhile, when P1 was getting executed, at the first millisecond, we can see that P3 has come and joined the queue. So P3 will be now waiting for the P1 to complete its execution. As known before, in 5th millisecond, P1 has completed. So P3 will get started to execute itself at the 6th millisecond. So the time taken to complete P3 is nothing but 5 plus 2, which gives you 7. Now similarly, P2 comes at the 2nd millisecond, waits for its chance, and now P3 completes only at the 7th millisecond. So it gets started to execute after 7th millisecond. So the completion time for P2 is 7 plus the burst time, which is 3, which is equal to 10. Likewise, sum up even for P4. Take the preceding process completion time and the burst time of the current process, which is P4. So we get the answer as 17 to be the completion time of P4. As said before, turnaround time is the difference between the completion time and the arrival time, right? So we need to find the difference between them. 5 minus 0 is 5, 10 minus 2 is 8, 7 minus 1 is 6, 17 minus 3 is 4. Yeah, so 17 minus 3 is actually 14. Okay, so next we are having waiting time. So waiting time is the time in which the process was in the queue, but it was not executed. We know that P1 didn't wait for anyone, so 0 is the waiting time for P1. P2 waited for 5 milliseconds. That was when P3 was getting executed and P1 was getting executed for 3 milliseconds. Okay, so P1 got executed for 3 milliseconds and 2 milliseconds was for P3, after which it got executed. So the waiting time is 5. Similarly, we have 4 and 7 for P3 and P4 respectively. So the next example which we'll be having now is how to represent a Gantt chart. Gantt chart is very important, So Gantt chart is the chart which represents the overall process. For example, how a CPU actually executed it. That is shown with the help of a Gantt chart. Gantt chart is normally used in order to represent the overall process which took place in the computer. Here you can see how it will be looking. So it's basically a box in which we will be having the processes and time slots written. So here is the pictorial representation. You have P1 which is occupying for 5 milliseconds. Okay, so 5 milliseconds is occupied by P1. Okay, then we can see that P3 occupies 2 milliseconds after 5. Okay, so we can actually write here as 5. Okay, here as 7, here as 10, and here we can write it as 17. This is a representation of Gantt chart. To make it even more pleasing, you can add different colors for different processes, and you can just write one single box for P1, one single box for P3, one single box for P2, and one single box for P4. That looks even more amazing. I hope now you've understood first come first served algorithm at its best. Thanks for watching.